doing. That's
Yeah, tell me
I've
what.
got it into that situation now, which is better. I couldn't get anything on this screen, and now so I'm fighting with that, and I got my Zoom to work under the Chrome browser on Linux, so I'm going to go with that for the moment.
Have you done the press escape or whatever to get access to the BIOS to do the recovery thing on that machine?
I I haven't done that. This is a company upgrade, and it's supposed to. It was working. It was working on the external display, but it won't work on the internal one. So I loaded the new drivers, and now it's doing this to me. So
Oh, be kind to your IT department. They're doing the best they can.
yeah, yeah. He told me how to fix it, and I got it this far. So we'll see. We'll see what happens.
How is my audio? Because I'm not using the mic that I prefer to use, but
It seems to be adequate.
yeah, I think it didn't pick up my Bluetooth mic and speaker when I rebooted here, so I'm having my challenges as well. Seems like Matt is coming online from two places. So from in my world, I'm trying to get my RPM measurement figured out. I'm trying to find a screenshot of the bad data. Bear with me a second. Matt, we can see you, but we can't hear you. Matt, while you're getting organized, I'm just going to comment on my current challenge. So what's here is a plot from RQT plot, and I'm displaying this ticks per millis data. And as a reminder, I'm trying to calculate my RPM using that magnetic sensor that's spinning at basically, well, it's spinning as fast as the wheel is times 2 because it takes 2 revolutions of the magnet every time the wheel turns around one time. And it was spitting out this data on RQT plot when I ran the Rosbag, which is like I was expecting numbers down here in the 130 range. And then ever so often I was getting, you know, this stuff like 1700. So I added more data to the Rosbag and then translated the Rosbag into a CSV file and started looking at the data. I sorted the data based on the highest number of ticks per millis. And it's saying the highest is 157, which is right down in here where I want it to be. But I'm getting all this RQT stuff. So now my problem du jour is why the heck is RQT telling me that I'm getting 1700 periodically, but this Rosbag CSV file is saying, no, your biggest number was 157. So that's a brain teaser. That's that's what I'm currently working on. What else is going on in your world, Jeff, besides fighting with the Windows machine?
Well, I got my the power drivers put in for my LEDs. That's all bolted inside now, and I got the thing all put together. And my wires were half an inch too short, so I had to get some extender, get an extender header and put on and run the wires out. So I got those hooked up, and I'm just trying to figure out what colors should blink under what situations, and that's what I was playing with last night.
That sounds like an awesome, fun thing to be working on.
And I said before that I had this hooked up, and then as soon as I started driving around, the LEDs would stop flashing. I thought it was some kind of an I2C problem. Well, I put in some code that said if you try to write and get any error, I just blatantly reset the I2C interface. And last night it sat there for quite a while running, and it never quit on me, but I didn't have any way to tell if it was actually resetting or not. So that either it got better or it either got better or it either fixed the problem or not, and I didn't have anyone to know if they did. But so that's where I was at playing with that. And the other thing is, I went to our robot meeting last night, so I pulled out my work laptop and I was going to put the code in so I could talk from my Linux machine down to my microcontroller. And that's when I found out my laptop, the screen doesn't work on it. So, but I just now got it to the point where I got something on the screen now, so it's getting better. So I got it back to the point where it's running again.
It's just being
We'll see what
happens. The other thing I'll just share that, let me pull up some code here and show you what's, I'm looking for some code here. Bear with me. It's not coming up in my recents, which is annoying. The subject is using the Teensy internal timer versus programmatically using a timer. I have up to this point, I've been using, what I will basically call a software derived timer. So this is the loop of my program that checks the RPM of the wheel in order to calculate the speed. And I was using this, basic command of setting the interval to, I think I've got it at 33 millis, so basically 30 hertz process. And it's just this if statement that fires on, that interval. And so Matt was offering up an alternative, and that is to use the hardware timer inside of the Teensy to fire this code, put this in a function and have that function run it, a hardware timer based thing. So if I can't get my RQT plot issue figured out as to what's causing that, then I don't know if it'll help to do it with a hardware-based timer, but that's another alternative. The other thing, in one of the calls, it may have been a Monday evening call when Kyler was suggesting using a USB, that he liked USB, and then I think you mentioned, hey, if you're using USB for other stuff, use USB for your 8-channel relay. So my 8-channel USB-based relay showed up. So if I have some time, I'll play with that and get it to working. So that's what's going on in my world. Jim, anything you want to share?
See if I can get the video started here. Well, we're way back to the basics. I picked up a game controller that has Wi-Fi functions, USB functions through a dongle, and Bluetooth functions. So we're in the process of just trying to figure out how do we, without actually having a game connected, and a lot of the software associated with this particular controller is game related. I was just trying to find some generic software that allows you to see Bluetooth connections or Wi-Fi connections at that level. I noticed that there is a ROS module, and I haven't explored that one yet. But besides ROS, how does a person see what's happening on a Bluetooth connection at a very basic level? That was the question in my mind.
I'm not, let me pull something up here. It might help, it might not, but share. So over here in the ROS Lawn Tractor section, I don't know if you've, when I was on my journey to try to figure out how all this stuff worked, I installed trying to make this bigger. So just getting TurtleSim up and running for me was, you know, a monumental feat for a while. And then these instructions, you know, I wrote, hey, here's how you, on a command line, get the thing to move. And then I went through, you know, so now let's use the gamepad to move TurtleSim. And so there was a joystick command and some this was a command that would let you see the output of what's going from, you know, as long as your joystick is showing up in your dev input devices, then you could do a test to see what it was outputting.
So does the dev input look at all the different inputs, whether it was a USB or a Wi-Fi connection or a Bluetooth connection? Does it just automatically find it?
So does it automatically find it? I mean, you're going to have a driver. I mean, if it's a Bluetooth device, you're going to have to go through a pairing exercise. If you go through your Linux-based pairing exercise, then although I've never used a Linux gamepad, I'm going to say yes, it's going to show up as an input, but only after you've done the Linux level pairing between the two devices.
Yeah, that's kind of where I was at that point. It was like, I'm not sure where to go next to find that particular driver for this generic gamepad. So we're just poking around, hoping, well, is it an Xbox driver? Is it a, you know, everything wanted to be a specific game controller. Kind of where we got lost then, just trying ones to see if they would work.
Did you buy it new, or did you just pick it up someplace and you don't have any packaging or, you know, manufacturer information?
The manufacturer information suggests that all the games will respond to it, but it's very game specific. You have to have a certain game software is where their instructions directed me.
I mean, if you just so have you can't even type. I mean, is there a Bluetooth? Is your PC Bluetooth enabled?
Yeah, I actually, at one point through, I think I was running the Windows software at the time, got it to pair up on Bluetooth, but then couldn't reconstruct that pairing again. So we just stumbled into accidentally getting to pair once with Bluetooth, but not having any other game connected to it to go any farther. That was where we were stumbling that evening. So that led me back to the generic question would be, at that point, so we have, say it's got a Bluetooth connection. Is there some more basic operating system software in Windows, and then also, Ubuntu we need to explore, where you can see once a Bluetooth device is connected, what kind of input, even at a digital level or whatever, where a person can see what's going on.
Yeah, I mean, I don't know what, you might have a particular reason for wanting to use Windows. I wrote these instructions because I was trying to, move into the ROS world and getting it to drive TurtleSim. I don't know is the answer to your question about trying to, in Linux, you can CAT the output, CAT the output once you've got a device to show that the data is coming through. You could then, write a Python script to read the data, but you got to get the OS level recognizing the device is out there. In Windows, you do that with the device manager, and in Linux, I'm a novice at best. This is how you see whether it's being recognized or not.
Yeah, appreciate the input, but that's just where we left off the last evening, spending about an hour trying to accomplish a task, and decided that we needed to find some more driver information, especially in Linux or Ubuntu.
Jeff, anything resonate with you about how to get a Bluetooth gamepad paired?
I would search for Linux generic gamepad Bluetooth and see if you can find somebody else going through the steps, because there's got to be other people that have tried this and made this work. So possibly if you can just find somebody's blog where they said, I tried to make this work and here's the steps I did. I guess that's what I would do, is go down that path. I've only tried the game pads with the USB connector on. I've never tried the Bluetooth, so I don't know what's actually involved in that. And if just doing a generic search on Google doesn't turn up, and then go to ROS Answers and put in Bluetooth gamepad at that point, and because that'll be people specifically trying to get it to work with ROS. So that might be a better place to look also.
Yeah, I mean, and just to echo Jeff's comments, I mean, I know when I wrote those instructions, it was keep it simple. A USB connection is one less thing to try to debug than trying to go to a radio frequency driven Bluetooth device. But if that's all you got, that's all you got. Anything else, Jim, coming up for you?
The only other question we had is resolution on a wheel encoder. I'm going down the path of just a 24-tooth sprocket with a sensor that senses each tooth passing the sprocket, which isn't high resolution by any sense. It'll get me down to half-inch or so accuracy. I couldn't really see any reason needing to go any higher resolution. Any feedback on how much resolution a person should really have on a wheel sensor?
I don't know if Matt's going to be able to come off of mute. I mean, I'm going to tell you, here's the lay of the land from my perspective. Jeff, Matt, and I have all used slightly different approaches to calculating wheel rotation. And having said that, Matt has said to me personally, hey, I'm not sure you need to worry about this whole wheel encoder stuff very much, because if you have an RTK GPS, you're more than likely going to get all of the location data that you need from that. So no doubt that will likely end up being true. I'm still trying to get my encoder working. I've used a magnetic thing that's produced by an Austrian company called AMS. Jeff has a rotary encoder, quadrature encoder, I think it is. And Matt has the inductive sensor that has about the same resolution that you're talking about. I'm not sure I ever heard Jeff talk about what resolution his has. Mine has some crazy level of resolution, 2 to the 16th, which ends up being like 65,000 ticks. So that's my sort of brain dump on what's the three approaches that each of us have used. Jeff, anything to add to that? How many ticks does yours give?
Mine's like 40,000 or something per revolution of the wheel. Some big number. I don't remember what it was. And quite frankly, I don't know the answer to how much do you need. You know, is a low resolution encoder tell you what you want to know? If you're just trying to get speed out of it, possibly a low resolution one works. But if you're trying to record both wheels and then rebuild odometry from that, so you can tell your position and your heading from that, it may require the higher resolution positions. But without trying it, I can't say right offhand. I guess one thing you could do is if you have a high resolution encoder, just blatantly divide it down and make it a low resolution and then run it through the equations and see what comes out of it. But I'm not. That's what I was going to do last night at the robot meeting, and then I couldn't get my computers to work, so I didn't get the code put in to do that. But that's something you could, once I get mine running, I could try that. I can divide it down and say, okay, here's the lower resolution. At what point is it adequate? At what point is it not adequate? And then a lot of it depends on what you're going to use the information for once you have it. So
the other thing I'll share is, part of the reason I've been beating my head against the wall trying to get my magnetic one to work is I want to also use the same sensor for angle sensing. And there I want as much resolution as I can possibly get. So that's why I've spent the time trying to figure out this magnetic one from AMS.
One of the reasons, having not actually looked at how a processor deals with counting the input, I can assume there's two different methods. You know, if a processor is running fast enough, it's looking at the input every single cycle, then it's software dependent. Is it actually picking up each tick depending on how the software is compiled, whether the software is actually looking at it every cycle? So I didn't know if it's any more burden on a processor, or is that input already occupied, period? It doesn't tax the processor anymore if it's looking at it 16,000 times a second, or if it's looking at it 10 times a second. Any thoughts on high resolution being a burden on a processor?
Well, I have some painful but precise information in that regard. This is my code that I'm using on my speed detector. Let's call it the speed detector. And so I've set this interval at, this is my main loop, and this is my read command of my, it happens to be an I2C sensor that, detects position. this Teensy processor is, just amazingly fast, and there is no, at 33 hertz, this thing is not taxed whatsoever.
Okay.
And let's see, I'm trying to figure out how to convey this. I keep track of the number of readings that I'm getting. But with so in 33 hertz, generally speaking, at 1 meter a second. So imagine this: the wheel is the vehicle is moving at 1 meter a second. This thing is firing every 33 milliseconds. This sensor is 65,000 ticks per revolution. I'm getting 5,000 ticks every time this fires. So, time period 1, let's just say this reads position 1. Time period 2, this reads, what did I say, 5,000 ticks? So, and the Teensy is, it has so much power that I'm not even touching it, because it's just a really super fast device. I don't know if that helps. Does that answer your question?
So the ability of the Teensy to record the ticks is just strictly clock driven, and it doesn't affect any other software processing at that level. The Teensy can do those ticks regardless what other software is doing on board.
I think both the Teensy and so these are the commands that are being written when this thing is talking to, in my case, an I2C device. I think you're sort of asking how fast is the I2C device, because
Yeah, probably.
if I wound this thing up, I think I would be constrained on, I think the Teensy could drive the I2C sensor faster than the I2C sensor could drive, and my guess is it could go to 300 hertz without, I could probably read this thing at 300 hertz if I wanted to. So I think the limiting factor there is how fast the I2C bus and sensor would work versus how fast the Teensy would work, if that makes sense.
Sure. So just curious then, along that line, in the thought process of using the I2C bus and a sensor that does the count versus like maybe what Matt's doing, where he's probably bringing that Hall sensor or inductive sensor right into an input on the Teensy itself. What went through your mind on electing to go this route?
I want to get this sensor working so that I have all of that resolution and all of that performance in my steering angle sensor.
Gotcha. Okay.
I want to use basically the same sensor, Teensy combination for the left wheel, the right wheel, and the angle sensor, instead of having a different solution for odometry versus another solution for steering angle.
Would multiple sensors communicate all on that same I2C bus, or would that require separate connections?
My layout is this Teensy that's running this code is communicating back to ROS over a USB connector into the ROS, I'm going to call it framework. So everything's going to be communicating back to the ROS framework via USB. Between the Teensy and the sensor is I2C, but I'm going to have 3 I2C sensors, each driven by an independent Teensy, each connected to the ROS
Oh,
framework with the USB cable.
gotcha. All right.
So said the hopeful novice roboticist.
Yeah.
Whether that all works, we'll see.
Well, thanks for sharing.
Matt, are you having a mojito down there yet? It is like 3 o'clock in the afternoon, I think, there for you. Okay, well, Jeff, anything else?
I would point out you were talking about the types of sensors and the resolution and all this. And on mine, I'm using a quadrature decode. So it's an incremental encoder, but it has a phase A and a phase B that are overlapping. So if you're turning it forward or turning it backwards, it knows which way it's going, so it counts up and counts down. And now so the advantage of that is if you're driving along and you come to a stop and the thing starts vibrating back and forth, if you don't have the quadrature, it's going to just keep counting up. You know, as it wiggles back and forth like this, the number just keeps counting up because you only see the fact that you're getting pulses. Now with the quadrature, if it comes and goes this way, it counts up. It goes this way, it counts down. It goes this way, it counts up. So it keeps track of your position. Now the thing that Al's doing, where he's got an absolute encoder, he gets the same advantage because, you know, it's sitting here and say, here's a number. It goes here. Here's another number. If it goes back, you get the same number again. So his will also keep track of whether you're going forward or backwards. So that's an advantage to that. So like the way Matt did it with just teeth. He got teeth sticking up in one sensor, so they go by. It goes click, 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 and if it goes back and forth like this, it thinks you're still counting up. It thinks you're turning constantly, but it can vibrate back and forth and give you a problem. So that's just some things to keep in mind. I'm not sure that that's a major problem. I know on our first tractor we did, it basically had the same kind of thing where it just counted pulses on some internal gear type sensor. And basically, if you take the philosophy that you say, I want to move forward and you're getting pulses, then you assume it's counting up. And if you say, I want to go backwards and you're getting pulses, you assume it's counting down. So you just keep tracking your software which way it should be counting. So that way it's, especially with a low resolution encoder like that, you just simply say, if we're not moving at all, we just ignore the pulses completely. And then once you start moving, then you can start counting them at that point. So it's just a matter of how you implement it once you get to that point.
Well said. Yeah, I call that when you're not moving and you still get, it looks like you're moving, jitter. You got to filter that out somehow.
Especially on something like a garden tractor, it's got an engine that's running. It may, in fact, be just sitting there not moving. It could be the whole thing's vibrating enough that you will be getting pulses off that sensor. So it's really just a matter of saying, if we say the thing is supposed to be stopped, and just simply ignore the pulses coming in. So that's a way to handle that. And I was saying on mine that if I take the high resolution that's coming off the thing and just blatantly divide it down, that I could prove one way or the other. But in reality, I'd probably be better off putting another sensor on there that just is closer to like the equivalent of the magnetic sensor and the sprocket. Because otherwise, if I take a high resolution number that's keeping track of the direction and divide it down, well, that's not really the same thing as trying to sense a sprocket that's turning. So something I can think about when I get that far.
When you get past your status statements and representing those in the LED, I'm anxious to see that. Jim, by the by, I'll just remind you again, and I don't mean to blather on about it, but in the milestone plan out on the G drive, although these steps I think need to be refined and cleaned up a bit. We do have, the bills of material that we've been using. I mean, in my case, like this is the magnetic position sensor that, I got at Mouser. That's made by this outfit called AMS. And so there's other, the details about that there, if you want to look at any of that. And as far as I'm looking for maybe I don't even have it there. The gamepad, oh yeah, I just got a $20 gamepad from Amazon. Logitech was the one that I used, and that F310 was definitely wired, but that's certainly been good enough for me. Okay, Jim, Jeff, anything else? And I'm going to give Matt one final go before we close down.
I can't think of anything else right offhand.
Is it snowing yet in Minnesota?
Not yet. Any day though.
Jim, are you good?
We're good. Thanks, guys.
Matt? Okay, well, we want the guys in Argentina to come up and roar past us and go farther than we've gone. So help them out. I'm sure they will help us out. Ciao, guys.